today, on our next video, we are going to find mean using the MGF that we had already found on our earlier video. So the mean is just given us the differentiation of the d dt of a moment generating function, and at this particular point t must be 0. So this one is the same as saying d dt of et mu plus t squared silver squared over 2. So when by differentiating it, we are going to get to find our mean, and at this particular point t must be 0. So we are going to find our mean to be e. So I'll just differentiate that. This one is a u differentiation. So we applying the relevant formula of differentiation, we'll have et mu plus t squared sigma squared over 2 times, when I differentiate that one, I'll have mu plus, this is t, so it will be 2 will cancel, I'll have sigma squared t, and at this particular point t must be 0. So when I replace t to be 0, I'll have e raised to 0, which is 1, times mu plus sigma squared t is 0, so that one times 0, I'll have 0. So my answer, e power 0 is 1, so 1 times mu, the mean is just mu. Variance, to find variance, we are going to find the d squared dt, d dt squared, the d dt squared of mxt, and is just like saying that we are going to find the d dt of the mean that we had already found earlier, and the d dt of the mean, so it is just the same as d dt of et mu plus t squared silver squared over 2 times mu plus sigma squared t, mu times sigma squared t. So here we apply the uv, the product rule. We know that we have uv plus uv, u prime v plus uv prime. So whenever I integrate this, the u prime, now when I want my u prime, the u prime will be et, and remember this particular point also t must be 0. So I'll have et mu plus t squared sigma squared over 2. So I'm integrating this one. So by integrating this one, it is just this one. I integrate this one, then I find the derivative of the upper one, which is times mu plus sigma squared t plus, not plus, but times v, and my v is mu plus sigma squared t. So I can just say this one is squared plus uv. So u is this. So u is e t mu plus t squared sigma squared over 2 times the it is uv prime. So the v prime now here, by differentiating this, I'll have, because the derivative of mu is 0 because it's a constant, that of t is 1, so I'll have times sigma squared, and at this particular point we know that t must be 0. So when I start replacing t with 0, when t is 0 here, I'll have, this is 0 times mu, which is 0, and this is also plus 0. So I'll have e to 0 times, this is mu. So when I square everything here and replace it to 0, whatever I'll get, I'll just get mu squared, because this is already 0, so it will affect that one. So I'll have into mu squared plus, I'll close it, plus, when t is 0, so I'll have e 0, so it is just 0. It is here is e raised to 0 plus e raised to 0 times sigma squared times sigma squared. So my variance, which is given by the expected of x squared, the expected of x squared now will be given as mu squared plus sigma squared, and we know very well that mean, or the variance is given by expected of x squared plus expected, not plus but minus expected of x, but this time round it is squared. So my expected of x squared is mu squared plus sigma squared, then minus expected of x squared. So my expected of x was mu, so when we square it, we're going to get mu squared, so that my variance of x, or my variance will just be given as sigma squared. Thank you for watching. Keep on subscribing and liking the videos. Thank you.